Hello everyone and welcome to another lecture. Today we will be seeing how to solve ordinary differential equations with Mathematica. Differential equations are important when we try to model a physical system because most of the time we are interested in how things change with respect to a certain parameter. So as you can see, I have taken two examples and in this video I will show you how to solve them. So the command we'll be using for solving differential equations will be dsolve. This dsolve command will solve a differential equation, and if you put your cursor over here, you can see that it first takes the equation, then you have to specify the function that is u, or so to say the solution that you want out of this equation, and then finally you have to introduce the independent variable x. So let's type our first equation. So first we type x, you put a multiplication sign, or you can just put an space. So I'll be going with the multiplication symbol, and you type y prime of x, so that Mathematica understands that y is actually a function of x. Then you have to put double equals and you type x plus 2y. Again you have to specify that y is a function of x. And now we have to put y of t because that's the solution we want. And the independent variable, not y of t, it should be y of x. My mistake. And finally you have to specify the independent variable, that is x. If you do it, run the code, and you can see that Mathematica has given you the solution, and this c1 is an arbitrary constant. If you have some initial conditions, then you can get this value for c1, that is the value will be coming from the initial conditions. And we'll be seeing, by solving our second example over here, we'll be seeing that Mathematica won't give us any arbitrary solutions anymore. It will give us the full solution that is subjected to this initial conditions. To solve the second one, again you will type dsolve, and now first you have to put two curly braces. The reason being, you have to put this expression first and then you have to put this initial conditions. So that's why you have to put two curly braces, so that Mathematica will take it as a list. So let's type that. Notice that here our y is a function of t. So let's type y double prime. This double prime denotes the second derivative of t plus 4y prime. Again it's a function of t, so finally you type 4y of t double equals 0. And now you have to put the initial conditions. To put the initial conditions, just type 0 instead of t, that is, it's fixing the value for y when t equals to 0. And you put equals again, because you have to let Mathematica know that the left hand side is equals to the right hand side. And then you type y prime of 0 is equals minus 8. And then as before, we type the expression we want and the independent variable. If we run the code, you can see that Mathematica has given us the complete solution to the initial problem that was mentioned in 2. So as you can see, it's not multiplying the exponential with this thing. There's a way to do that. All you need to do, you just need to use expand and you can use either this complete expression or you can use the percentage. If you use the percentage, let's see what this gives us. Yes, Mathematica multiplied exponential minus 2t with this minus 1 plus 60. Now you want to see the solutions in a graphical manner. That means now we want to plot this solution. How can we do that? Well, again we can use plot. We can type this expression over here, that is coming from here, or this one, your choice. Let's type exponential to the power minus 2t minus 6 minus 2t, and we have another t, right? And we want to plot it, let's say from, let's see our boundary conditions. Both of them are at 0, and we want to, let's say, plot from minus 4 to plus 4. Again we want to label our axis and we want to select a theme, and let's say today we go with business. Let's see what that gives us. So we go for plot theme business, and we want to label our axis as well. So to do that, you type axis first, select axis and set it to true, and then you type axis label. At axis label, just bring up a list and just type T, and in the y-axis we are plotting. In the y-axis, let's say I want to type solution, just like this. And if we do that, this is our solution that is coming from the differential equation, right? And again you can also switch to scientific, any theme you want, just type like this, and there you go. This is how we can easily solve a differential equation using Mathematica.